Ê, anh em thấy làm IT không? Râu ria tóc bạc hết rồi nè. Bây giờ nó như là nó trở thành một cái chuyện rồi mình cũng dần dần mình quen nè. Qua lại thức khuya, đột ngột thằng CEO nó nhắn nó kêu mình là hey, tao có một cái buổi EMA với cộng đồng nhưng mà giờ tao bệnh tao nằm tao hết làm nổi rồi, mày cover giúp tao đi. Mà đặc điểm mà cái cộng đồng cái dự án mình đang làm nó bên châu Âu với lại ở bên Mỹ thì nhiều, do đó nó toàn là mấy cái EMA là toàn là 11 rồi 12 giờ đêm nó mở EMA ra, thì thôi cũng phải cover cho nó thôi, chỉ có 30 phút chuẩn bị thôi. Thì trong cái EMA thì mình phải update một số cái tình hình của cái dự án, về mình đang build cái gì, thiết kế làm sao, mục đích nó là cái gì, bla bla bla. Thì mình nói về Agentic Data Coordination Service, nó giống như là một cái platform để cho mọi người cung cấp data và cũng cung cấp giống như là một cái knowledge base cho các cái con mà AI agents nó đọc. Thì cái data của mình đã làm thành cái dạng vector sẵn rồi, thì giống như là sau này những cái con knowledge base mà những con AI agent mà nó cần cái knowledge base gì thì nó chỉ cần nhập cái hash vô thôi là nó có nguyên cái đống kiến thức đó để nó trả lời người ta. Nó đại khái vậy. Và mình cũng nói thêm về một cái Multichain Oracle. Mình có kinh nghiệm làm Oracle, giờ anh em lại đang muốn build thêm một cái Oracle mà nó chạy trên Multichain, kiểu như là kết hợp với Oracle với lại Layer 0, Axela, nó chạy trên Multichain. Đấy, ngoài ra mình cũng có, mình sẽ nói về một số cái như là các cái fully on-chain AI agents để đưa các cái con agent nó lên chain. Tại vì theo một cái thống kê thì các cái giao dịch on-chain nó hiện tại là chỉ có 30% là bot, còn con người thì vẫn nhiều. Thì nó theo một cái dự đoán và theo cái trend thì mai mốt là sẽ là 70% là sẽ là AI trade trên chain, còn con người sẽ interaction ít lại. Đó, thì cái đó cũng là một cái đề tài khá là hot trend. Thì từ lúc mình lên cái vị trí này thì công việc của mình là vậy đó, không có code nhiều nữa mà cứ ngồi nhìn các cái trend đó, xong rồi mình thấy là các cái vấn đề gì chưa được giải quyết hoặc là những thằng nào nó giải quyết chưa tốt thì mình sẽ vẽ ra những cái giải pháp để mình giải quyết người ta. Còn cái chuyện dev thì có anh em dev lo rồi. Đó, thì cái video này mình cũng không có chuẩn bị kỹ lắm. Video này là nó sẽ bằng tiếng Anh, do đó anh em nào mà muốn luyện tiếng Anh mà muốn nghe thì có thể vào nghe thêm để cho biết. Mà nếu chỗ nào mà chưa hiểu thì có thể comment hỏi mình sẽ giải thích kỹ hơn tiếng Việt cho anh em hiểu. Hoặc là có cái chỗ nào đó mình nói sai hay là mình nói chưa có đúng lắm, chưa hợp lý lắm thì anh em góp ý cho mình để anh em càng ngày càng tiến bộ nha. Anh em, mình là QuanIT và trên kênh của mình chuyên chia sẻ các vấn đề liên quan tới blockchain và AI. Yep, all good. How are you, man? Okay, thank you, Matt. I must take the stage now. So, hey guys, and nice to see you guys. It's been 2 weeks, and I started to love this episode where we can sit and talk. This is me, Calvin, your CTO. I think I'm gonna update to you about some technical stuff because I'm the one who running the team and I actually put hands-on some of these development. In the last episode, I talked about AI and AI 0.1, where we have all the LLMs and then we train them and then we use them. And then we have AI 2.0 with all the fancy stuff, ChatGPT, LLMs, RAG system, fine-tuning, LoRa, Quilora, all the techniques to make the AI so smart. And then I talk about data, which is where the AI and the blockchain meets. And I talk about just a little bit about rivals. which is the intersection between AI and blockchain. So we don't talk much about rivals. So in this talk, I'm gonna talk more specifically about what we've been working on, which is the Agentic Data Coordination Service, which is really cool. But before that, actually, let me get to a more interesting story about how we get attacked like hell in the last couple of months. I believe we have 2 attacks from some unknown attackers. So basically, we have a Kubernetes cluster that is run the backend, and then we have a database cluster. So in the first wave of attack, the attacker sends 190 million requests to our backend, so that it drowned the database. So with the first wave of attack, we did some upgrade, we do some caching technique inside the Kubernetes cluster of the backend. And then we also do some firewall rules and filtering, some advanced firewall rules, so that we can prevent the DDoS attack. And then we also increase the capacity of the Kubernetes cluster, also increase the pods from the database cluster. So this is the first wave of attack, and we was able to solve that. So in the first wave, the components that actually cannot handle these kind of insane amount of requests is the database cluster. So we fixed that by adding some more rules to the Kubernetes cluster backend. And then around 1 month later, here's come the second wave of attack. This time we received, when we look into the dashboard, it was 446 million requests per hour, if I remember it correctly. So the number of attack double up. So they kind of double the amount of DDoS attack to our servers. And at that time, the Cloudflare provider, they detected these insane amounts of requests, and then they keep blocking the request because we're running a couple of services to prevent these DDoS attack. But then it accidentally blocks some of the requests from our clients as well. So if you guys running the CLI of the our client, you're going to see some data and disconnected and some reconnected. And if you run into the website, you will see some disconnections on the API. Sometimes the data is not allowed correctly. And what a coincidence that even the X space with Elon Musk and Donald Trump got DDoS like crazy, and he even spent an hour fixing that. And that was a very interesting experience. So I received the request for support, and I check and I see that there are millions of attacks on the Cloudflare dashboard. So I gather up all the team and say, hey guys, what are we gonna do? So we come up with these solutions. So the solution is, at the first layer of contact, which is on the Cloudflare layer, we create multiple workers so that the workers will act at the first layer of defense. We set up rules for all those workers, and then we set up 3 more database and backend cluster. So we have one in Voucher, one in AWS, one in Google Cloud. So we have 3 clusters right now. And then when the request coming in, the worker will filter all the DDoS attack, also check if any database and backend cluster is available and have the least request to handle, and then forward the request and then get the request and then return back to you. So after we implemented, it took us around 3 hours to set up two more database and backend cluster, and then do all the coding and deployment for the Cloudflare worker. And it was quite pleasant. And when we see that the number of requests coming keep lowering down, so it comes to over 400 million, and then just fall down, and then we keep monitoring, and everything is into it right now. So TLDR, I would like to say thank you to all these attackers, because obviously to send this insane amount of requests, they have to spend
a bunch of money on the infrastructure and also on resources to produce those requests. And I just want to thank them for testing our system and make us understand what is the weakness and how to fix it. So that was all the story about the attack. And and that was the story. And let me actually share something more interesting to you guys. Can I share my screen now? And then, okay. So actually, this is still work in progress. The ADCS, which stands for the Agentic Data Coordination Service. We've been working on this product for a couple of months, and I've been working on the structure design, and this is still a work in progress because you can see in the design there is still lots of comments and a lot of things to optimize, but I cannot wait to share with you guys the product that we've been working on. So the ultimate goal of this system is to create a service where people can actually come in and request for the data. And also there's going to be a bunch of factors that come in to create all the data adapter, create all the categories and aggregate the data and then package it up. Then if some factor they have the resources and infrastructure, they can actually run these adapters and aggregator and store it inside of the database. So as you can see here, if you want some data, you can simply request us, and then inside of the component we have categories, we have adapter, and we have aggregator. So why we have to come up with all these kind of designs? Because the challenging thing for this kind of system is that you need to have a system where people can request any kind of data, but different kinds of data must reach a standards of data. So the data have to be cleaned up, it has to be in some certain format. If it's a string, then it has to be in a certain format, or if you want JSON or you want a number or a byte, so that's all different. So that is the challenging part. So we try to design this so that it is generalized enough to provide a standard, but it's also flexible enough so that anyone can request any piece of data. And one important part of the ADCS system is we come up with two data form, so that different factor can use different types of data. So we can use like normal type like a MongoDB or PostgreSDB to request the data and then come back to your applications and use it. But in case you are running a AI agents which require the data in a vector format, we also provide that via our rival storage and OrbitDB system. And OrbitDB is like it's just a vector DB that is run on top of IPFS. So you can the AI agents can actually query directly the data inside the vector DB. All it needs is just the IPFS hash of that piece of data, and they can do the magic. So the challenging thing about this is how we make sure that all the data is sufficient and all the data come in the required format and it is legit. So that is why we come up with another system for these data. We call this data provider. Maybe in the future we come up with some names that make more sense, but for now we just think of it as a data provider, right? Okay. So these guys, they come in and they run the preset of adapter and aggregator and fetchers and blah 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 inside this structure, and then they provide the data. So technically they can provide anything. They don't have to run all the data, they don't have to aggregate the data, and some malicious factor may come in and provide some malicious data. So that is the problem. That is why we come up with a reputation system. So decentralized is good. Decentralized approach going to be a good approach for this use case where you have to do some staking, and we have a reward and slashing mechanism for all these providers, because the provider, they actually provide the infrastructure, so they have to pay the money, and in order to incentivize them to do that, to provide the resources for us, we have to have a reward mechanism. So for example, you run your infrastructure for a couple of months, you provide a lot of data, then you get some token in reward. But in the opposite side, if you're trying to do some malicious stuff by reporting false data, or your infrastructure is not up, and then sometimes you're just not online, you're not doing the work that you're supposed to do, then we're gonna slash the money in the reward and slashing mechanism. So you can also this one is a really interesting concept that we're still working on. So we start with data feeds, and with data feeds, in some use cases, some specific use cases for AI agents, they need something that is like more faster and real time. So we come up with a data stream. So the differences between the data feeds and the data stream is that the data feeds will act with a request and respond pattern, where you request and the system respond. But with the data stream, we're going to open a data pipeline so that the data can flow into the AI agents or any system. So we start with data feeds, and then we start expanding to and exploring the options of providing the data stream to all different apps and AI agents. So that is the story. I'm going to talk a little bit about data feed and data stream, because it happens here. I used to work on Oracle system, so these kinds of concepts we may be very confused, and some developer, they prefer to use data feeds with a really fast pace, so that it looks like a data stream, but it's not a data stream. So with data stream, the use cases where you can actually do something like you subscribe to a data stream, and then you do a catch on a specific event. So you constantly check for the data flowing in, but if some piece of data that meets a specific criteria, you can trigger a bunch of actions that follows that. So that is the really powerful use case of a data stream compared to the data feeds. So we start with data feeds, and then we slowly move on to the data stream options. Also, we have some other factors like the admins, so that we can actually go and check the category, because anyone can jump in the platform, and then they declare a new category, and then inside of this category they declare new adapters and also different kinds of aggregator. So maybe the data source is not available, or maybe the data is just useless. So some people may provide or propose some data that actually no one used, no one needed. So we have to be really strict. So we're still brainstorming on this, because we can actually decentralize these admins as well. And also we have a okay, let's talk about the reputation system, right? So this one is the whole ADCS design, and we have the reputation system here because we don't have much space, so that I split it up as a reputation system. So with the provider, before they can provide the data to the ADCS data warehouse, they actually have to go to our dashboard, and then they have to do some register with their wallet or any other authentication types that can actually sign the data. So they have to register their wallet. They have to stake the token. We have not decided yet on the slashing and rewarding mechanism, but it's high. There's a high percentage that we're going to choose some kind of token so that they can stake. And then after signing and register the wallet, they can actually start to download our SDK and start up all these components. And with these validators, this one is still a work in progress. I'm still brainstorming on this a little bit. But what coming up in my mind right now is that it can come up in some form of RAFT consensus mechanism where the validator will pick this data. So let's say this validator want to test and want to tag a bunch of providers with these categories. So they're going to run the same thing as the provider running, and they do comparisons. And if the result is in a threshold, or if the result is the same, then the provider is doing a good job. And if the provider is not doing a good job, it's going to tag this provider as malicious, or they may shoot a message. And all of these validation, we're thinking of submit it on chain. So there's a bunch of approaches for the proof on chain, and we're also working with some of the partner. So we may come up with a simple approach with running RAFT consensus mechanism and then save it on the blockchain, on our blockchain, on any other blockchain, or we can do it with a bunch of partner that actually provide these verifications and proof methods like Iron Layer, or we can do it with Babylon, or we can do it with Meta Layer from Caldera. There's a bunch of partners we've been talking back and forth. And that is for the reputation system. And beside for that, one of the small assignment for that is we are trying to work on, so these are technical stuff about the RAFT mechanism. If we have more time, then we can talk about this. But actually what we're trying to working on is that we are working on a multi-chain oracle, which is like a part and a branch of the ADCS system. The idea is that with oracle system, they need to have some kind of submitting on chain, and our approach is we can do it multi-chain. So we have solutions with layer 0 or Axela or Meta Layer, or this guy will provide us the ability to deploy one smart contract and it become available on multi-chain. And when we do the data submission, we can actually do one submission and the data become available on multi-chains as well. So this one is some kind of design for the data feeds. So we have the pull pattern, and then we have the request response pattern. And this one is a classic one. So if you are familiar with Oracle system like Chainlink or Supra, Oracle, or Redstone, or the Oracle system, they use the same style like this. And we are trying to do what we're trying to do is we try to create a Oracle where you can actually do a request for different types. For data feeds, every provider, they are focusing on pricing data. But for us, we're going to come up with an Oracle system where we can provide up to 10 or 20 different kinds of data. So for example, you can request for the price, you can ask for the liquidity of a specific pool, you can request for the best yield farming platform with the highest APY, blah, blah, blah. So we come up with a bunch of data points, and we're going to work on these request response data feed pattern. And the important part is also the ADCS data availability layer, which we will spread to V1 and V2. So at first stage, we are planning to do the data availability layer with the fetcher and aggregator, and then store that in a centralized database. But when we are expanding and we have a lot of partners that are willing to run this node for us, we're gonna switch up to data availability layer V2, where each node will contain its own database and its own data, and it work on a consensus mechanism. So for each node that is fetching, then all the nodes is updated with the most updated data, and then the user can actually pull that data from the data availability layer and then fit that to the contract, and then it's go multi-chain. So this is a really interesting idea about Oracle. And for some explanation about the consensus about between the nodes, so each node gonna have a local aggregate where they grab the data, and then is synced with other node. So after all the local aggregate is synced together, it becomes the global aggregate. And with the specific consensus mechanism called RAFT, we have not decided on which consensus we're going to use, but there's a high percentage that we're going to use RAFT. They will vote for a leader so that the leader can start submit. And this is the breakdown structure of what is inside the node. Of course, we use Redis, we use DB, we have the admin components, fetcher, aggregator, reporter, and everything is working fine. It's building us for a couple of months. And the ultimate goal of all these structure, and actually I can share you this. This one is a bunch of approaches so that we can put the AI agents on chain. So AI agent can now actually use our data and actually read the data in the blockchain and then actually send the transactions to the blockchain and even send the transactions to multi-chain. So this is a really powerful function for an AI agent to perform. So this is a bunch of stuff. We can do like a account abstractions, or we can do a chain service for AI agents so that they can call it to different methods and performing all the operations, or we can just like simply put the private key somewhere where the AI agents can know the private key and then make the transactions. And so the ultimate goal of this is to create a data market that allows the AI agents to fully go on chain. And of course, if that can happen, then the possibilities is endless. And so after the ADCS overview, we are planning to release the ADCS toolkit as well. So it's going to be a toolkit that's specialized for AI agents if they want to go on chain. So everything is ready there. You can grab the data, you can do some analytics, you can use the tool to read the data on chain, you can use different tools to do a RAG system, and then you can also send the data on chain by sending a transaction through your AI agents. So that is the ultimate goal of the whole system. And that's it. That's all I want to share for today. This progress that we've been working on for a couple of months now. And thank you guys for listening, and back to Matt.